Out in the distant reaches of our solar system, beyond the familiar 8 planets, lies a realm of celestial objects that have challenged our understanding of the cosmos. These are the dwarf planets, a class of worlds that share characteristics with both planets and smaller bodies like asteroids. The story of dwarf planets begins with the discovery of Pluto in 1930. Initially hailed as the 9th planet, Pluto's small size and unusual orbit raised eyebrows among astronomers. As telescopes improved, more objects similar in size and orbit to Pluto were found in the region beyond Neptune known as the Kuiper Belt. This raised a fundamental question: what defines a planet? The discovery of Eris in 2005, an object even more massive than Pluto, forced astronomers to confront this question head-on. Pluto, once considered the 9th planet, holds a special place in our hearts and the history of astronomy. Discovered in 1930 by Clyde Tombaugh, Pluto remained a point of fascination for decades. Despite its reclassification, Pluto remains a captivating world worthy of our attention. Images from NASA's New Horizons mission in 2015 revealed a surprisingly diverse and geologically active surface. Vast plains of nitrogen ice, towering mountains of water ice, and hints of a subsurface ocean paint a picture of a world far more complex than initially imagined. Pluto's largest moon, Charon, is so large relative to Pluto that the two bodies are often considered a binary system. Eris, discovered in 2005, threw the astronomical world into a frenzy. Larger than Pluto and located even farther from the Sun, Eris's discovery reignited the debate about what constitutes a planet. Eris resides in the scattered disk, a region of the outer solar system beyond the Kuiper Belt, populated by icy bodies with eccentric orbits. Its surface, reflecting sunlight as brightly as freshly fallen snow, suggests a composition of methane ice. Eris's discovery highlighted the limitations of our previous definition of a planet. It became clear that using size alone as a criterion was insufficient, as there were objects in the outer solar system that rivaled or even exceeded Pluto in size. Haumea, discovered in 2004, stands out as one of the most unusual objects in the Kuiper Belt. This dwarf planet is a rapid rotator, spinning on its axis once every 4 hours, making it one of the fastest spinning large objects in our solar system. This rapid rotation has distorted Haumea's shape, giving it an elongated, cigar-like appearance. Haumea's unusual shape is thought to be the result of a massive impact early in its history. This collision would have also created Haumea's 2 small moons, Haumea and Namaka, and scattered debris that forms a distinct family of objects in the Kuiper Belt. Observations of Haumea and its family members have provided valuable insights into the composition and evolution of the outer solar system. The discovery of Eris and other dwarf planets forced the astronomical community to confront a fundamental question: what is a planet? The new definition established 3 criteria for an object to be considered a planet. It must orbit the Sun, be massive enough for its gravity to pull it into a spherical shape, and have cleared its orbital neighborhood of other objects. Dwarf planets, while meeting the first 2 criteria, failed to meet the third. Some argued that Pluto should remain a planet, citing its cultural significance and the fact that it was considered one for over 70 years. Others supported the new definition, arguing that it provided a more scientifically rigorous and consistent classification system. The debate over the definition of a planet highlights the dynamic nature of scientific understanding. Dwarf planets, relics from the early solar system, hold valuable clues to the processes that shaped our cosmic neighborhood billions of years ago. Their distant location in the cold depths of the outer solar system has preserved them in a pristine state, relatively unchanged since their formation. The composition of dwarf planets provides a glimpse into the building blocks that form the planets we know today. Their icy surfaces and potential subsurface oceans offer insights into the distribution of water and other volatiles in the early solar system. Studying these objects can help us understand the conditions that led to the formation of Earth and the emergence of life. The orbits of dwarf planets also provide valuable information about the early solar system's dynamics. The Kuiper Belt, a vast region beyond Neptune, is a treasure trove of icy bodies, including a significant population of dwarf planets. Named after astronomer Gerard Kuiper, this region is believed to be the source of many short-period comets that grace our skies. The discovery of Eris and other dwarf planets in the Kuiper Belt has revolutionized our understanding of this distant region. It is now estimated that hundreds of dwarf planets may exist in the Kuiper Belt, each with its own unique story to tell. Studying this diverse population of objects provides valuable insights into the formation and evolution of the outer solar system. Spacecraft missions like NASA's New Horizons have provided unprecedented close-up views of Pluto and other Kuiper Belt objects. The discovery of Eris and other dwarf planets has ignited a new era of exploration in the outer solar system. Astronomers are now actively searching for more of these distant worlds using increasingly powerful telescopes and sophisticated detection techniques. New surveys are scanning the skies, looking for the telltale signs of dwarf planets, faint points of light moving slowly against the background of stars. These surveys are expected to uncover hundreds, if not thousands, of new dwarf planet candidates in the coming years. The discovery of more dwarf planets will not only expand our catalogue of solar system objects, but also provide a more complete picture of the Kuiper Belt's population and dynamics. Dwarf planets, remnants from the early solar system, offer valuable insights into the processes that led to the formation of planets. They represent a stage in planetary formation that was halted before these objects could grow to the size of the terrestrial or giant planets we see today. By studying the composition and structure of dwarf planets, we can gain a better understanding of the building blocks that came together to form larger planets. These objects provide a glimpse into the conditions and processes that operated in the early solar system's protoplanetary disk, where planets formed from the dust and gas surrounding the young sun. The gravitational influence of dwarf planets also plays a role in shaping the structure and evolution of planetary systems. Dwarf planets act as time capsules, preserving the history of our solar system in their icy and rocky bodies. These distant objects have remained relatively unchanged for billions of years, offering a pristine record of the conditions that existed in the early solar system. By studying the surface features, compositions, and orbits of dwarf planets, scientists can piece together the events that occurred during the solar system's formative years. This knowledge helps us understand the processes that led to the formation of planets, moons, and other celestial bodies. The data gathered from missions like New Horizons, which provided a close-up view of Pluto, and future missions to other dwarf planets, will continue to unveil the secrets locked within these ancient objects. Each discovery adds a new piece to the puzzle of our solar system's history, helping us understand not just where we come from, but also the potential for similar processes in other star systems. If you learned something new from the video, then please give a like to video and share your opinions in the comment. And don't forget to subscribe for more such content and also share it with your friends and families. The study of dwarf planets, far from being a niche area of astronomy, has profound implications for our understanding of the solar system and beyond. These distant worlds challenge our assumptions, expand our horizons, and provide valuable insights into the formation and evolution of planetary systems. Dwarf planets serve as a reminder that our solar system is a far more diverse and complex place than we once imagined. They highlight the limitations of our previous definitions and classifications, forcing us to rethink our understanding of planetary formation and evolution. The exploration of dwarf planets has already yielded groundbreaking discoveries, revealing a surprising diversity of surface features, compositions, and even the presence of moons and rings around some of these objects. If you learned something new from this video, please give it a like, share your opinions in the comments, and don't forget to subscribe for more such content. Also, share it with your friends and family.